Oh, forgot to open up the right slide deck. And it's the wrong one. File. This one. All right. Welcome to your summer semester. Yay. I get to spend time together in the summer. It's right. It's nice right now. Wait till it's 30 degrees. We'll see what B building's like. I do know during the summer, the upper floors of B building, you'll want a sweater. Oh yeah. The hotter it is outside, the colder floors 3 and 4 are. Yeah, it's like there's literally a 5-degree difference between 2 floors. Just warning you now. And then if you have one on the ground floor, it's even warmer. So it's like the opposite of what you'd think about how heat works, but you know. All right. I guess I get to skip the about me because you guys know me already. Okay, best practices for success. Guess what? The exact same thing I told you guys last semester. Come to lecture, come to labs. I record my lectures. The course moves quickly. That's a lie. This one's actually really nice and slowly paced. I just threaten people that don't know that it moves fast. However, missing a lecture can still be a problem. Again, I record my lectures, so at least you get to have it after the fact. But that having been said, it's better to be here because you can go like this, can ask questions, you know, the usual. All the course materials on Brightspace. There are actual things to read on Brightspace for this course, actual PDFs to do the hybrids. It's basically put a bunch of documents I put together years ago, and they've just been reusing them ever since. So recommend that you read the slides before coming to class so that there's no surprises. And I am going to be using lots of slides, at least for the first half. Even for the second half, because this course is just theory. Pretty much all theory except for like a little bit. You guys know my routine with Brightspace. Finish the labs. You guys have Sir Fraz as your lab prof, which is right before this class. Yeah, but he's just before this, which of course he's like, oh, this might be a problem. I go, no, it's not. Don't worry. I've taught this long enough. It's not a problem. It's been planned. So Fraz has been teaching at the college for a while. I don't know if he introduced himself fully. He just showed up and says, I'm Fraz, I'm your lab prof and onwards. He's quite comfortable with pretty much, at least with the first half of this course, he's going to be very comfortable with. Second half, if we were using Oracle, absolutely. He's got a bit of a learning curve with the MySQL stuff, so it's cool. Also, if you have problems with your Macs, he's going to send you to me because he's not a Mac guy. So just saying, it's good that I'm on the same day so that after the lecture, I'll have some time to help you because the lectures are actually fairly short. Like they booked you 2 hours, and for like half the semester, lecture's like an hour long. So you actually have an hour you get back. So my usual rules for labs is, you know, late 20%, more than a week 0, but you'll have to confirm with Sir Fraz if he's going to follow the same rules because the lab is his to do with as he wants. And as always, get your classmates to help you as much as you can. Your classmates are your best resource. Okay. Now that we're done the stuff I've already told you guys, you know, 17 weeks ago. What are you going to be learning? Week 1, an introduction to data modeling and database design concepts. Week 2, normalization. Normalization is actually probably the hardest topic of this semester. We get it over with early. A lot of profs will argue about when you should teach normalization. Should it be later? Should it be earlier? In my experience, it's always been good to get it over with early. Like, you know the expression, rip off the Band-Aid? Because, you know, if you take your time, it just hurts more. right? So normalization is the hardest topic this semester. So you know, I, I've been told I do a pretty good job covering it, but you guys get one lecture on it. When I went through school, I got 3. So we'll see how it goes. Um, you're going to learn about diagramming. Uh, remember last semester I said, when we talk about diagrams, you're going to learn about that next semester? It's happening. The physical database design process, including, how to pick your data types and stuff. We're going to talk about indexes and views. The views, you guys had like a 30-second introduction to it last semester. We're going to talk about it more, at least, a whole minute. But we're going to talk about views, we're going to talk about indexes. Then we'll have a review period. You'll notice that there's actually a lot of wiggle room. And then we have your midterm test in class, same as always. Then you have week 8, which is your study break. FYI, during this summer study break, I am not in Ottawa, so don't even try reaching me during that week. Oh yeah. Going where the cell phones don't even work. Theoretically, I've been told cell phones don't work there, so I'll be spending a week in a boat fishing, so that's the plan. Week 9, backup and restore. We're going to learn what you guys are now. We're going to get to the administration side of database. So first half is the theory of creating structures. Second half is the actual mechanical whoops scenarios. Week 10, database security. As good as your backups are, you want to make sure people aren't allowed to touch your things that aren't supposed to be able to touch your things. Then we talk about triggers. Not the kind that send people off the deep end. We're talking about database triggers. Store procedures and functions. And often weeks 11 and 12, I smush together because it's pretty much the same topic, just slightly different application. Week 13, we talk about transactions. One of the most important topics when we talk about the mechanicals of a database. Not a hard concept to grasp, but it's very important. Then we have a review. And then on week 15, we have our final exam. Good news. There's no practical assessments. So you don't have that stress. It's labs. So there's no, but there's tests. No, that's not what I just said. Not a good sign, my dear. Okay, there's no practical assessments. You know how you had to do those 2 practical assessments in level 1? There's none of that in level 2 for this course. I don't know what the other courses. Literally, this course, the practical part of the grade is labs. 9 of them. There used to be 10. Then I realized it was really stupid to do a 9 and a 10 when they're the same topic. So I put them together as one big fat lab. So it's worth a little more. So lab 9 is worth a little bit more than labs 2 to 8. Lab 1's not worth a whole lot because it's get your shit set up. So yeah. That was perfect. That was perfect. So the labs are worth 40% of your grade. Okay. The midterm is worth 25% of your grade. The hybrids are worth 10%. Final exam is worth 25. So it's actually a little more on the theory side than the practical side. It used to not even have this course. I don't know why, but at some point, so I taught this course years and years and years ago. And then they gave it to someone else for a while and they took the hybrids out. So you're literally your midterm and your final exams were worth 30% of your grade each. I'm like, that's kind of absurd. So I brought the hybrids back, give you guys a chance to earn points somewhere else. These hybrids have been used many times, so they're fairly stable. Lab 9 is worth less because it's set up your software. Lab 9's worth more because it's a bit bigger. So often what happens is at the end, there's almost like a dead lecture. And usually for that, I'll actually do a demonstration of the last couple of topics. I do an in-class demo of the application of, so that you have a bit of a practical concept behind it. It's a 324 course, 2 hours of theory, 1 hour online/hybrid, 2 hours of lab, 4 hours of study time. That 4 hours depends on who you are and how fast you absorb material. The second half, I don't think you'll need the 4 hours. Just saying. All right, I've already talked about the college services to help you guys last semester, so if you need anything, feel free. Cal, if you need help because you have ADHD or neurodivergent or insert physical challenges you may have, peer tutoring, $8 an hour, and they have financial assistance if you can't afford the $8 an hour. Considering you have to work for like 45 minutes if you're earning minimum wage, Algonquin's mental health support services, if you're having a rough time, there's actually counselors to talk to you. And there's a bunch of other options you can go look at. I usually talk about the food options during the summer semester because there's none. So B, cafeteria doesn't open at all in the summer. It's a good thing because it's terrible food. Every single time I've eaten there, I've gotten not sick, but I haven't felt great. I think the cafeteria in CA is open because a lot of the trades programs run all summer. They're legit. Their food's good. Wolf's Den is open. Observatory's closed in the summer. Bits and Bites and Tea Building, I think, is closed in the summer. So main caf and CA are your best bets for food. Or just go off campus because you're going to pay the same price and it's not any better. Okay. Now to get to the meat and potatoes. Do you guys have anything you want to ask me before I dive in? Yeah. Yeah, except the documents are all in Brightspace. So it's download a PDF, read it, take the quiz. Same deal as before. I just have to actually make sure they're actually published. The course layout is exactly the same. I designed both courses, or at least I redesigned level 1 so it matches level 2. Yeah. And I meant to ask you guys, did you have a good break between the two, like those 2.5 weeks? Was it reasonable? Yeah, that's good. I just spent the last 2 weeks sitting on my couch playing Expedition 33. So, probably one of the best games I've ever played. Like they've sold 2 million units in 2.5 weeks. That's probably best-selling game ever. And it is worth every penny. If you don't mind a challenging gameplay with a side of depression. If you've played it, anybody who's played knows exactly what I'm talking about. You haven't played it? Play it. Even if you're not you don't like playing games, it's worth learning how to play it. No. Basic story, which is not a spoiler, is something terrible happened in the world. At least that's how it starts. And every year there's a countdown on a pillar, and every year that number goes down by 1. Anybody who's that age, if you were 34 when it turns down to 33, all the 34 people die. If you're 34-year-old, you die. So then the next oldest generation is what's left. And every year they send an expedition to try to stop this from happening. So this is Expedition 33. So every single character is at most 33 years old because all the 34-year-olds died. And that's the premise of the start of the story. It's dark. It's a fantastic game. The story is amazing. Just saying, it's not a big studio. Fantastic voice acting. Just worth playing it. Claire Obscure Expedition 33. Just Expedition 33. No. Windows, Steam, PS5, Xbox. It's been a fantastic way to spend my time off. All right, now to actually get to course material. All right, so we're going to talk about data and information. Good, my mic is actually on. It just hit me that my mic, I might have turned off my mic between classes. I didn't. Whew. All right, introduction to data information, database design process, and fundamental database objects. Okay, so what is data? Data is a thing. You guys know this by now. It's a thing. It's specifically a thing that people want to keep track of. And as we all know now, somebody wants to keep track of something, of everything. There's somebody who wants to keep track of anything in your world. Somebody wants to keep track of it. Usually the big IT companies, Google, Apple, Microsoft, Facebook. Now, that thing can be almost anything that can be described. If you can describe it, we can shove it in a database. These things would be a person, an event, an object. There could be things that even are undefinable, not an object, like the weather. It's a thing. Sounds like the stupidest way to describe data, but it's literally you're just describing a thing. You can take this description, you shove it in a database. That's the world of a database. So data versus information. And often you'll hear arguments about data versus information because depending on who taught you, you tend to start using one phrase or the other. I try not to. So when you talk about data, it starts out in an unorganized information. It's in a raw state. Basically put, it's like I look around the room and I can, in a raw state, he's got a hat. He's got a kind of a pink shirt, she's got a pink watch. That's just raw information that I'm seeing as I look around the room. And then that raw information gets transformed into a proper database structure. So somebody would go around and say, okay, how am I going to keep track of all these data points? Then they create a structure, which is what the first half of this course is about, is figuring out how to take this information, put it in a structure. And then it becomes organized information derived from structured data. So you have data coming in, you have data coming out. But the difference is the stuff coming in is a mess. And if you did your job right, what comes out is not a mess. It's usually somewhat structured, somewhat organized, sometimes very confusing if the structure gets very big. So how does data get organized? Step one, proper planning. You want to understand what it is you're working with. Then you are going to have a series of diagrams because your database diagram gives you a visual way to understand what it is you are working with. You have conceptual diagrams, logical diagrams, and physical diagrams. Logical and physical diagrams are almost the exact same thing. They both contain data types, they all have primary keys, they all that fun stuff. However, the logical diagram, it can be ported between database servers because it's abstract. The physical one is specific. So if you create a physical diagram for a database for MySQL or MariaDB, it will not be the same as a diagram for Postgres or for Oracle because it's specific, right? We could, the easiest example I can use for this is a car, right? You have a car. It has 4 wheels. It has a method of propulsion, whether it's an electric motor or gas. It probably has seats and a steering wheel and some pedals. It's a car, right? However, it's going to be a Mitsubishi. That means it's going to have very specific parts inside the Mitsubishi. It's a Honda. It's going to have very specific parts from a Honda. It's a Nissan. It won't have a transmission. because that's just Nissan. Depends on what your car. Sorry, I just have a dislike for Nissans. My daughter had one and the transmission literally fell out of her car. So not a good time as a high school student. Uh, but have but once you get to the physical side of it, you can describe it logically, and then you have the physical that actually has the manufacturer specific parts in it. That's the difference between logical and physical. Conceptual is a very high level version of the diagram. Anybody here draw? Actually, draw. You never draw a final piece right off the bat, right? You sketch it in first, and then you fill in the details. A conceptual diagram is a sketch. You are putting an overview. And then we have normalization. So that's, happens somewhere in this process. Normally, after conceptual, before logical, you get normalization. So the design process is a circular process. You identify the data, you normalize it as much as you can, then you diagram, you review, identify any shortcomings, rinse and repeat. It's just like the software development lifecycle, but applied to data structures instead. Just like the software development lifecycle, SLDC, you have a spec, you write some code, QA destroys your code, you fix your bugs, there's a review, you do the next spec based on whatever you did before, rinse and repeat. And it doesn't make a difference whether you're doing agile or waterfall, the steps are all the same. It's just agile, they happen a lot faster with a lot smaller pieces. That's literally the difference. Don't let any agile scrum masters ever hear me say that. Okay. So identification. Identification is also known as defining the data source. For example, if I say I want to define a student, so we're going to do a data structure for students. We have to define what describes a student, right? So typically you'd have first name, last name, student ID, email address, phone number, mailing address, current living address. If you're an international student, they probably have a copy of your student visa, I'm assuming. They probably have your passport number. Maybe not. I don't know what they track. If you're a Canadian student, they'll have your SIN number on file. I don't think they ask for gender anymore, but once upon a time they asked you, male, female. Now it's, whatever. Uh, they'll ask your date of birth. These are all things that help define a student, the entity known as a student. So the identification process is identifying all things, and then you describe each of these things. So when we talk about here at the school, we've got students, we have profs, we have courses, we have programs, we have sections, we have rooms, we have all these things, and they're all related. Because right that example alone right now, you've got students, teacher, there's a course. You have a section, which happens to be the same thing as the course right now because there's only one section. You have a classroom. You have a booking for the classroom, right? All these things are all entities that are all related to each other. They're all described different. Well, teachers and students are fairly closely, 90% the same. The classroom has very different properties than a student, right? Classroom has a number, has a maximum number of students, that kind of thing. Now, that's when you're identifying things. However, there's another step before you start identifying each of the individual things is where's this information coming from? So there's 3 common sources for where this information comes from. You have an existing database that needs to be modernized. The school is currently going through this exercise. I don't know what's happening now that their budget is gone, like negative, big negative numbers, lots of red everywhere on the balance sheet. But when an existing, for example, the student information system, as you guys know it, Access, right? Algonquin College Student Information System. In case you were wondering what those letters stood for, it's being replaced because Access is written in COBOL. We're still running the same system from the 1970s here. They just keep patching it and updating it. Um, yes. So they're replacing it. So they're doing an exercise of moving from the existing data structure into a new data structure. There's a clean room implementation. That's personally my favorite way of doing things because it lets you do whatever you want. Usually a clean room implementation means your boss went on a vision quest, came back with a fantastic idea, and now you got to make it happen. And if you're a new person working with databases, you'll prefer working with an existing database. If you've been doing this for a long time, you'll prefer the clean room implementation because you have less cruft. You might be digitizing existing processes. That's not happening as much as it used to, unless you work for the government. Surprisingly, a lot of stupid Excel documents and Word documents, um, as I'm discovering in my career. But back in the day, you used to get a receipt on a piece of paper, right? You still do when you go to the grocery store, but they give you a choice to email it now. Um, used to be when you would go and order something from a catalog. I don't think there's enough people in here the right vintage to have ever experienced this. But you used to get stuff in a catalog and you'd write it down on an ordering card, then you'd mail it in with your credit card number. So that was a manual process that's been digitized over the years. Um, then there's other sources depending. Where you think information could be created, that counts as a source. Okay, fundamental database objects. Now you guys have played with tables, right? So at least that's not a mystery. However, before we get to tables, there's three fundamental database objects in the design theory side of it. They're known as entities, attributes, and relationships. You guys have experienced the relationships already on the physical side. There's actually a conceptual side to it. Entities become tables, attributes become usually columns or fields. So there's like you can almost draw a line, you go from entity to table to physical table, and you got an attribute becoming a field that becomes a column, essentially. All right. Entities are the fundamental object in all database design. Entities describe the items or the things you're trying to maintain information about. In this case, students are an entity. A an entity class is just usually shortened to entity. So you'll sometimes read a piece of text that says this entity class this, entity class that. They just mean an entity. They just decide to put more words. It just means entity. An entity eventually becomes a table, as I described. What the difference is, though, is you have an entity, which is a student. You have an entity instance, which is each of you. Each of you are an instance of a student. So we have an object called student. Each of you are copies of the student with totally different values, but you are just an instance of that object. Just like this room is an instance of a classroom. There's one upstairs, there's one downstairs. They have different names, slightly different properties, different number of doors. The doors are in a different place. Like for example, the one right upstairs from here, the door's there, not there. Just, Um, so each instance is a single, basically an instance is a record. So when you were doing, select star from whatever table and you had a bunch of rows that came back, each of those rows is an instance. As it says down here, an instance usually becomes a row. Okay. Um, I literally just finished describing this slide. I just talked through it already. So an entity is described by its attributes: student, course, locker. Every instance of a given entity will always have the same attributes, but the values change. Like all of you have a name, all of you have an email address, all of you have a student number, but the values that go into it are different. Except for that one semester where I had 4 Mohammeds in my class at the same time. I'm not joking. Literally, I had 4 Mohammeds. Just one of them is Mohammed is spelled differently. But uh, apparently, it's the father's name gets carried to the last name, and blah blah blah, and they just keep using it over and over and over again. Um, you know, I got nothing to say. I mean, one of my friends is Hubert the Third, so I cannot. He called his son Hubert too. It's a family tradition. The men called there's just Hubert all the way down. The oldest is always called Hubert. It's just so funny. But yeah, so entities, but even all those Mohammeds had different email addresses, different phone numbers, and a different student number, right? So might have some commonality between them, but there's always going to be something making them unique. Yeah, exactly. Or you end up with all the Priyankas in the world, where first name Priyanka, no last name, or Priyanka. So in Algonquin, you have Priyanka or Priyanka period, because our system requires a last name. So because there are parts of the world where people don't have last names, or just depends on what kind of mood, I guess, whatever, or culturally, depending what subset of people they are, they have a last name or not. It's entertaining, things you learn over the years as a prof. Okay, so when we talk about entities, there's actually multiple flavors of these entities because what's theory without complexity? All right, so a strong entity is an it's a piece of data that can live on its own. All right. So, for example, a student would be considered a strong entity. We can add a student to the system without needing anything else to define that student's existence. Not talking about, a title like Mr., Mrs., PhD, whatever, but we are able to add you to the system as a standalone thing. We don't need anything else to define that student. Self-contained. Another example would be a customer record. How many of you shop online? Pretty much everybody now, right? And you have an account with said shopping service, whether it's Amazon or whatever. Your customer record is a strong entity because you create an account before you check out. Therefore, the customer record can exist without anything else. Exactly. So the customer record can exist without anything else defining it. So that's a strong entity. We have weak entities. A data instance in a weak entity cannot exist without something else defining it. We all have that friend who cannot exist unless somebody else defines their existence, whether it's their significant other or their best friend or their mother, right? We all have someone in our lives that are like that. That's a weak entity in the real world. In the database world, on the other hand, a good example is a payment on a loan. You cannot make a payment on a loan that does not exist. Can you imagine you walk into the bank, you say, take my money. Here's a payment. For what? I don't know, just take it. The bank won't take it because they have nothing to apply it to, right? So a payment cannot exist without a loan or a credit card or whatever, car payment, whatever. If you do not have a physical, like a loan, you cannot make a payment. Therefore, the payment is a weak entity because it cannot exist without something else to define it. So on the other hand, the loan can exist without the payment. Tell me how I know that. You'll learn as you get older. Go buy a house. Um, attributes. Attributes describe an entity. We've already had the conversation about what describes a student. So you have a pretty good idea when I'm talking about attributes. It's the things that define an entity. Normally, it becomes a field or a column in the database. Not always. Sometimes they get discarded. I'll be talking about a bit about those later in the course. But usually things that are considered derived values are not stored. For example, I can give you guys a really easy example. You would never store an age in a database. You change their data, you store the date of birth because you can always calculate how old they are based on now minus date of birth tells you how long they've been around, right? So something like an age would get discarded in the design process because it's derived. You don't need to keep it unless it's for performance reasons. But then you have to do something to keep that up to date all the time. So it's, you're adding complexity in a different place. Um, During the conceptual design phase, attributes do not have data types. We describe an object, student has a student number, a name, an email address, and a phone number. We don't talk about what kind of data type it is. We know we have these pieces of information. During the physical design phase, attributes might be split up. In other words, if we just say, oh, we've got to track a student's name, in the physical design stage, we might want to break it down to first name, middle initial, last name. They could be combined. Sometimes it'll happen that you actually want to take a couple of things and put them into one. Not often, but it happens. Or they might get dropped all outright, like age. So there's a few different kinds of attributes. You have identifiers. These will become your primary keys, potentially. We will be talking about identifiers next week in detail. We have atomic attributes. Atomic attributes are attributes that contain a single value. Date of birth. Everybody only has one. Oh, everybody only has one date of birth. And it's a single value. End of story. You have composite attributes. These are attributes made up of multiple pieces. For example, a person's mailing address. At the design stage, we go, student's got an address. Cool, good, done. However, think about that for a second. What makes up an address? You got your street address, postal code, city, state, province, region, whatever you want to call it, country. And depending on what kind of systems you're using, you may have your address broken down into multiple pieces with the street number and the address, or the address and the unit number, right? Depending on what your data needs are, you may break that down even further. That's known as a composite attribute. It's something made up of more than one piece. Composite attributes get broken down at the physical stage because you don't want to have that. Exactly. Multi-valued. Multi-values are basically a list of values. For example, at first we say, hey, we are going to define an employee and we want to list their skills. So we just have an attribute called skills. But you can have, if you're an employee, hopefully you have more than one skill. Therefore, it's a list of values. Later on, those will be dealt with. But at the conceptual stage, maybe not. Just depends what kind of person you are when you do that design. Derived. I already talked about that. Age is the easiest derived attribute I can use because it's calculated. Your order total is another good one, right? You got your order line, which is 3 pounds of bananas at 79 cents a pound. So 3 times 79 cents, that's your line number, and then you got a loaf of bread at $4. You take those two numbers, you add them up, and that's your total. Those are all derived values because you can calculate the value of a field based on other data in that database. If you can calculate the value of a field without having to require additional input, it's known as derived. Then we have optional attributes where it's not required to define the entity, but might be useful. For example, um, Back when I went through school, they asked you for your home phone number, your current living phone number, and a fax number. Cell phones were like really expensive when I went through school. Like, I think you paid some like $60 a month for like 15 minutes of talk time. It was really expensive back then. And it didn't work in most places. So out of those, the fax number would have been optional because not everybody had a fax. Nowadays, you'll have a home phone number and a mobile number. Most people provide just the one, either a home phone number or a mobile number. Or if you're smart like me, you keep your home number and get rid of the phone line. And you just put a forwarding on it. So it just rings on my cell. Magic. But it's an optional attribute. So, example of attributes. I mean, I've already done this. I'm not going to go through that again, but you guys get attributes would describe something. Now, relationships. So, relationships is where the concept of relational database comes from. When you hear a relational database, that's because of the relationships inside of it. They define how various entities are related to each other or how they're interconnected. Now, the cool thing is that in all database servers, regardless, everything is one-to-many at the physical level. But when you're doing a concept side, there's three kinds of relationships. One-to-one. One-to-one relationship means that each entity is related to each other just once. The easiest example here at the school for you guys is lockers. You are allowed one locker. And technically, according to the system, a locker can ever only be rented by one person. Yeah, we'll have people rent a locker and 5 people throw their shit in it. But on record, one person's tied to that locker, and that locker can only ever belong to one person at a time. So it's a one-to-one relationship. One-to-many. Prof, many students. You know, loan, many payments. But it's a one-to-many. And then you have the many-to-many relationship, also known as the Kentucky relationship. And the older I get, the less people get that joke. Everything's related to everything else. Hillbillies. Yeah. There's certain parts of the world where their lineages get a little weird. But essentially it means that something can be related to many. For example, a really good example actually, when I say prof to students, it's not really a one-to-many relationship. It's a many-to-many relationship because I have many students, so I've got 2 lecture sections, and you guys have many profs because you have, prof per how many courses you're taking this semester. So you have a many-to-many relationship. There's a many-to-many relationship between professors and students. In the instance of this course, it's a one-to-many. But in the grand scheme of things, it's a many-to-many. There's a many-to-many relationship is physically impossible to define in a database server. You always have to do something to get around it. There have been a few database servers that allowed many-to-many, and it's never ended well. Yeah, yeah, we'll be talking about that later this semester in a couple of weeks. But essentially, many-to-many is physically impossible. In a database server, it's a concept. And I just described one-to-one, student locker. There you go. I can skip this slide. One-to-many relationship. This one's always fun. It's a goose and egg. A goose can lay many eggs. Each egg ever comes out of one goose. Right? Because that egg, only one goose. But the goose can fire out those eggs. Or chicken's even better because they constantly put out eggs. And then student courses is many-to-many. I used the prof example, but each course has many students and each student is enrolled in many courses. So it's a many-to-many relationship. Okay, so the good news is this first week, the content's pretty light. We actually end fairly early. like literally 45 minutes. This today's concepts were literally just um, terminology, so that when I start talking next week, it makes more sense. Like you've seen these words, and I saved a lot of time because I don't need to show you guys where what the course shell looks like, because you know exactly what my course shells look like, because it looks exactly like level 1. I am going to go make sure that everything is working properly though, for you guys, because I realized that there was a bit of a quirk um, with the hybrids, because they weren't showing. Yes. Again. Okay, turn that one on. For some unknown reason, Brightspace decided to hide all my hybrids on me. Even though you can see I've got a start date set, that's when it's supposed to magically show up for you guys, but it decided to make them to hide them from you. June. Hey? Uh, oh, come on. Are they? Well, no, not that one. I'm gonna go fix those dates when I get home. Um, which explains that one's right. Hang on here. May 25th. Yeah, that's right. Oh, it's just the years are wrong. Let me go. Let me go record how terrible I am. Update. I actually changed all the dates, but I forgot to change the stupid years. And this one. Yeah, that sounds right. There, done. That's fixed. That's going to show up properly. And let me go check the labs and make sure that they're showing up properly with the right dates. Yeah, that one's right. Hey, week 8 is the week before Canada Day. You still get Canada Day off, but you have school on the 30th, the day before. Don't I know it? Okay, so that's about it. Outside of that, yeah, you guys are free to run. Go take a little break before your next class, and I'll see you guys here next week.